Okay, so problem number 89 has this weird x squared minus 2x to the negative 2 to the 10. Okay, so it wants to know where is the constant term. What is the constant term? Okay, so there's a bit of a trick to this that you can do kind of longhand. It would make this work. Let's ignore that for a second and let's look at something simpler like a plus b. There's a binomial. It's a binomial, right? A plus b to the 0 is 1. A plus b to the first is a plus b. A plus b to the second is a squared plus 2ab plus b squared. A plus b to the third is actually a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so there's a pattern here. If you look, in each time I iterate, I start with the highest possible power of a, and I go down a cubed, a squared, a, and then no a, and then I go no b, b, b squared, b to the third, so it goes up, right? So, like, I know, like, a plus b to the 10th is going to be a to the 10th something, a to the 9th, b, a to the 8th, b squared plus, out to, a, b to the 9th plus b to the 10th. Alright, I know that that's there, but I don't know what the coefficients are. So what happens here is if you follow the coefficients, I get a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This follows a thing that's called Pascal's triangle. So let's look at what that is. So Pascal's triangle looks like this. And I'm going to get a bunch of rows of this. So there's 1. And then we saw that the next one is 1, 1. And then what we do is we put the 1s on the end and we say 1 plus 1 is 2. Okay, and then you get 1, 3, 3, 1, because with the 1s at the end, 1 plus 1 is 1 plus 2 is 3, 2 plus 1 is 3. And then we do that again. And I have to do this until I get to the 10th power, which is kind of big, but we're going to get there. So that's the 5th power. This is the 6th power. Okay, this is the 7th power. This is the 8th power. It's got a neat little symmetry to it. The 9th power. 6 and that's 15, carry the 1, 70, 85, is that right? 29 and 56 is 85? Yeah, that's good. 56 and 70 is 126. Another 126, 56 and 29 is going to be 85. 37, 9, 1. Okay, so let's do the 10th power. Let's see, that one's going to be 46, 122, 211, right, 252.
Alright, so you have about 10 more minutes until you can take a break before you meet with Mr. Murphy. So you go back to your independent
Okay,
work.
so what does this have to do with my problem? Alright, well, this is the row I need, right? So literally my guy is going to be like x to the squared to the 10th, right? Plus 10x squared, right? 10x squared to the 9th, x to the negative 2. There's a negative 2 in there too. Negative 2x to the negative 2 to the first, right? And it just keeps going. Okay, so this is my construction. The question is which one is the constant term in this? So let's take a look at something. Let's just play shape. Just lop that off. I don't want to do that. Okay, so if I just expand a little bit here, something becomes really obvious. If I had like x squared minus 2x to the negative 2 to the 0th, I get 1. X squared minus 2x to the negative 2 to the first, I get x squared minus 2x to the negative 2. And then if I go x squared minus 2x to the negative 2 to the second, I'm going to get x to the 4th, right? Plus 2 times x squared times negative 2 times x to the negative 2 plus 4x to the negative 4. And watch that, because that and that cancels and makes that negative 4. So the middle term of these the even number expansions, that's going to happen always in the middle term of the even number expansions, is going to become a constant. Woohoo! All right, so let's look down here. The middle term would have a coefficient of 252. So, looking at that reality, that thing is going to have a middle term of 252, right? And then we're going to take x squared, right? And that's going to be, the middle term would be 5 and 5, so that's going to be x squared to the 5th. And then we're going to take negative 2, x to the negative 2 to the 5th. That would be the middle term. So I get 252, x to the 5th, right? And then this is going to be negative 32, x to the negative, that's going to be x to the 10th now, right? And negative 10th, right? So these fall out, making negative, and then I need 252 times 32. 8,064, which is our answer. That's the constant term of the 10th expansion of x squared minus 2x to the negative 2. It's a tricky problem, but, you know, we got there.